Problem number 12, we have in the standard xy coordinate plane, the point 2, 1 has the midpoint of CD, and is the midpoint of CD, and point C has coordinates 6, 8. What are the coordinates of point D? All right, we have a problem with our coordinate plane, so let's draw our coordinate plane. It's always good to draw a picture when the problem is talking about a picture, right? So it's our graph, we have y as our y-axis, we have x as our x-axis, standard xy coordinate plane. The point 2, 1, so if we go over 1, 2, up 1, that is the midpoint of CD. So we have some line segment CD, remember this is a symbol for line segment. Point C has coordinates 6, 8, so 1, 2, 3, 4, 5, 6, up 1, 2, 3, 4, 5, 6, 7, 8. It's going to be somewhere up here. Okay, this is 6, 8. Okay, now a couple ways to do this problem. This is point C equals C. That's our point C right here. We know that this point here equals M, our midpoint. Okay, so what we can do is use our growth triangle, which is just finding the slope here, to do the same thing over here and find that point D. We know D is down here somewhere, but we don't know exactly where. Because remember, the midpoint is the point that divides the line segment in 2 equal halves. Okay, so one way to do it would be to just count. So let's try that. That might be the easiest way. So if we go down, how many? We're at 8. We have to go down to 1. So 1, 2, 3, 4, 5, 6, 7. And then we go over 6 to 2. 1, 2, 3, 4. So this is 4. So we've gone down 7 and over 4. So we do the same thing here. We go down 7. 1, 2, 3, 4, 5, 6, 7. And over 1, 2, 3, 4. Kind of just estimating with our graph. We see that this is going to be the midpoint. Okay, it's not exact because it's just a sketch. We go down 7 over 4. Now, what is this point? We've gone down 7 from 1. So that'd be 1 minus 7, which is negative 6. And our point here, so this is like a negative 6, our y value, and our x value is 2 minus our 4. So that'd be like negative 2, so our point is negative 2, negative 6. So it's a great way to visualize it with solving a picture. If you have graph paper, you could be super exact with those measurements and have it super accurate. Another way to do this problem is mathematically. So we have the point C, right? We want to find the x distance and the y distance away from the midpoint. So our x value here, so we have 2 points, right? We have C, which is 6, 8. We have our midpoint M, which is 2, 1. Okay, so to find the x distance, we can do x minus x. So 6 minus 2 equals 4. That's our x distance. And then 8 minus 1 is our y distance. So 8 minus 1 equals 7. And you see that the number is reflected up here. That's when we counted, right? We had 7 and 4, right? We had 7 for our y, which is our y distance. We had 4 for our x, which is our x distance. And we can use that to do the same thing to find our unknown. Our unknown is d. Our d is some x comma y, right? So now that we know the distance, we can use the same type of equation. So we know we have 2, since we're going this way now, we have 2 minus something is going to be 4. Okay? So 2 minus our something, our x, is going to be 4. Remember, this one's x, this one's y. Now, we can solve this equation by subtracting 2 to get our 0 pair, and that'll cancel. Our negative x then will equal 4 minus 2, which is 2, divided by negative 1, and we have x equals, that's a positive 2. Positive divided by negative is a negative. X equals negative 2. Okay, we see that's our negative 2 right there. We can do the same thing, we can do the same thing for y. We'd have 1 minus something, our y, equals 7. So using the same type of equation, we solve for y by subtracting 1 to get a 0 pair. Then we have negative y equals 7 minus 1 equals 6. Divide by negative 1 to get 6 divided by negative 1 equals negative 6. Okay, so we can set up our equation to get the same answer of negative 2 for our x, negative 6 for our y, which we can see is the same as when we did our picture. So our answer is negative 2, negative 6 by doing it 2 different ways. Do whichever way is easiest for you because you want to be time efficient for the ACT.